Dear students, in the previous class we had a discussion over the intermolecular force and thermal energy. How intermolecular forces and intermolecular force and thermal energies are interrelated, and how it determines the states of matter and all that. Intermolecular force is inversely proportional to thermal energy. Thermal energy is directly proportional to temperature of the system. Whatever the temperature or heat we given to the system, the complete energy is called thermal energy. This thermal energy, as the thermal energy increases, repulsive force become more, interact or intermolecular forces decreases. Because of that, molecules goes par each other and the states of matter get changed. Correct? So these things were discussed in the last class. Today class we will discuss about the first state of the matter. That one is gaseous state. Okay, let us move to the gaseous state. Gases. The physical state of matter is completely depend upon the arrangement of the molecule. How the molecules of the matter arranged, based on that we classify the matter into three main types: solid, liquid and gases. In case of a solid, the molecules are compactly arranged, intermolecular force is more, correct, and the liquid, in case of a liquid, molecules are randomly arranged, intermolecular force is a little bit lower compared to the solids, and when we move on to the gas state, the molecules are far apart each other and this poor intermolecular force is observed. Okay, that means in gases molecules are far apart each other, very random arrangement of molecules is observed. So these part you are well known because these all things you already discussed in your high school study. In case of the gases, what are the important characteristics of gases and how many gaseous elements are there in the periodic table? There are 11 gaseous atom or elements are present in the periodic table. Element, I am talking only about element, not a compounds or combined state of the any other elements. Okay, I am talking only about the element. There are 11 elements. The all noble gases, gaseous state, oxygen, chlorine, nitrogen, so sulfur. So these are the gaseous molecules, gaseous atom. So there are 11 atoms. So what are the elements that are present extremely left or your right side of the periodic table? These all are gaseous atom. What are the characteristics we observed in the gaseous state? Gaseous molecules shows few a unique characteristic. These are gases are highly compressible. Okay, let us discuss one by one. The characteristic of gases is the first one, or better record it as properties of gases. One is gases are highly compressible. Gases are highly compressible. What is the meaning of this compressibility? Compressibility means after adding or applying pressure, you can convert into any other state. There is a possibility. There is no breaking of the system or the matter. Compression take place. So that one is highly compressible. Gases are highly compressible. What is the reason? Molecules are far apart each other. Because of that, compressibility is possible. When we compress the gases, it get converted into liquid state. This depends upon the temperature. Okay. Next, second possibility. The second property is density is lower than that of liquids and solid. solids. When we compare the liquid and solid state, gaseous state is compared to liquid and solid state, density is very low, poor density is observed. The molecules are far apart each other, therefore density is very low. Next, gaseous shows fluidity. Flowing nature, we have to call it as flowing nature. Gaseous molecules shows flowing. This shows flowing nature. Okay. So flowing of molecule, fluidity, it is called fluidity. Molecules moves from one part to another easily. Okay, so this is the another property. The same property we also observed in the liquid also. Okay, it is not a unique property. Both gases and liquid shows flowing nature. Next, flowing nature is observed. Next is gaseous molecules. Gaseous molecules exert pressure, exert pressure in all possible direction, all possible direction. We can observe the pressure or pressure exerted by the gaseous molecule. So possibility of exertion of pressure of gaseous molecule in all direction. So what is the meaning of this statement? Because of the flowing nature, it flows or it moves any direction. Similarly, it exerts the pressure in all direction, all possible direction. Okay, so or we can apply pressure in any direction also, it is also possible. The reason is gap between the molecules. There is a large gap between the molecules of the gases. That is the reason of exerting the pressure in all possible direction. Suppose ನೀವು ಚಾಕ್ ಪೀಸ್ ತಗೊಂಡಿದ್ರಿ, ಓಕೆ, ಸಾಲಿಡ್, ನಾವು ಇಲ್ಲಿಂದ ಪ್ರೆಷರ್ ಹಾಕ್ಬೋದು, ಒಳಗಡೆ ಇರೋ ಮೊಲಿಕ್ಯೂಲ್ಸ್ಗೆ ಪ್ರೆಷರ್ ಅಪ್ಲೈ, ಸೊ ಇಲ್ಲಿಂದ ಅಲ್ಲಿಗೆ ಹೋಗಬೇಕು, ಸರಿ. ಇನ್ ಆಲ್ ಪಾಸಿಬಲ್ ಡೈರೆಕ್ಷನ್ ಇಸ್ ನಾಟ್ ಹ್ಯಾಪನ್ಸ್. In case of a gases, it is possible. Also, gases are solid molecules. These molecules attractive force is observed inside. Correct. The molecule which present inside the chalk piece is pull towards the molecule that are present on the upper side. Okay, ಒಳಗಿರೋ ಮೊಲಿಕ್ಯೂಲು ಮೇಲಿರೋ ಮೊಲಿಕ್ಯೂಲ್ಸನ್ನು ಅಥವಾ ಸುತ್ತಲಿರೋ ಮೊಲಿಕ್ಯೂಲ್ನ ಒಳಗಡೆ ಎಳ್ಕೊಳ್ತಾ ಇದೆ. ಸೊ ಗ್ಯಾಸಸ್ಸಲ್ಲಿ ಆ ಥರ ಇಲ್ಲ. Because molecules far apart each other, there is no force of attraction. So because of that, it exerts a pressure in all possible direction. Okay, so these are the very important properties of gases. There are a lot of properties, and another properties depends upon the shape and volume. This is the basic property, shape and volume. What is the shape of gases? What is the volume of a gases? So there is no definite shape, but indefinite. So volume and shapes are indefinite, or there is no not definite shape and volume is observed. It gain or acquires the shape and volume of the container. ನಾವು ಯಾವುದರಲ್ಲಿ ಹಾಕಿಡ್ತೇವೆ, ಸೊ ಅದರ ವಾಲ್ಯೂಮ್ ಅವರ ಅದರ ಶೇಪ್ ಅನ್ನೋದು ತಗೊಳ್ತದೆ. ಈ ಕ್ಲಾಸ್ ರೂಮ್ ಆರ್ ನಿಮ್ಮ ಮನೆಯಲ್ಲಿರುವ ಗ್ಯಾಸ್ ನಿಮ್ಮ ಮನೆಯ ಒಳಗಡೆ ಇರುವ ರೂಮಿನ ಶೇಪನ್ನು ತಗೊಳ್ತಾ ಇದೆ, ಅದರ ವಾಲ್ಯೂಮ್ನಲ್ಲಿ ಫಿಲ್ಅಪ್ ಆಗಿದೆ. ಸೊ ಇಟ್ ಅಕ್ವೈರ್ ದ shape and volume of the container. So these are the 5 very important properties of gases. These properties are not important for your exam point of view. Okay, so these are the properties we should know to study of the gaseous state. By knowing these property and observing the nature and the behavior of the gases, different scientists give the different statement on the gases. It is completely behave or completely depend upon the behavior of the gases. Different scientists explain or give the statements. These are considered as a law. These are all the laws is combinedly called as gas laws. Okay, so this is the your main syllabus of this topic, gas laws. Okay, let's move on to the gas laws. This is a very important concept for your study, gas laws. How many gas laws and what are the statements involved in the gas laws? There's several gas laws. According to your syllabus, there are three important and again another one van der Waals. Okay, that part you are already studied in a first topic. The same thing repeated in this topic also. Okay, let us discuss about the gas laws one by one. The first law is first law was explained by Robert Boyle. According to the Robert Boyle, or in his experiment, he concludes that when pressure is applied on any gases, the volume of the gases decreases. When you apply the pressure, volume of the gases decreases. When we release the pressure, then volume of the system or volume of the gaseous system increases. Okay, for Kannada medium student, ಪ್ರೆಷರ್ ಅಂದರೆ ಒತ್ತಡ. ಓಕೆ, ಪ್ರೆಷರ್ ಅಂದರೆ ಒತ್ತಡ, ವಾಲ್ಯೂಮ್ ಅಂತ ಹೇಳಿದರೆ ಅದರ ಗಾತ್ರ. ಸೊ ನಾವೇನು ಮಾಡ್ತೇವೆ, ಇಲ್ಲಿ ಒತ್ತಡವನ್ನು ಹಾಕಿದ್ರೆ ಗ್ಯಾಸಸ್ಸಲ್ಲಿ ಅದರ ವಾಲ್ಯೂಮ್ ಏನಾಗ್ತದೆ, ಕಡಿಮೆ ಆಗ್ತದೆ. ಸೊ ಒತ್ತಡವನ್ನು ನಾವು ರಿಲೀಸ್ ಮಾಡಿದರೆ, ತೆಗೆದರೆ ಅಲ್ಲಿ ವಾಲ್ಯೂಮ್ ಇನ್ಕ್ರೀಸ್ ಆಗ್ತದೆ ಇನ್ ಗ್ಯಾಸಿಯಸ್ ಸ್ಟೇಟ್. ಓಕೆ, that thing observed during his experiment, it is accidentally observed. Okay, not there is no intention to identify and all that, so it not happen. According to Robert Boyle, okay, that become the first law. Okay, the first law is called as Boyle's law. According to Robert Boyle, he gave the relation between pressure and volume. How this law explained in this case? According to the statement, at a constant temperature, okay, so what is the important condition? Temperature should be constant. At a constant temperature, volume of a given mass of a gas varies inversely. Okay, varies inversely with pressure. Okay, so this in this statement we saw or we come across the three different words: temperature, volume, given a mass of a gas. Given a mass of a gas means amount of a substance, and the last one is pressure. So you come across four different words. These four are the properties. Okay, these are the four are the very important properties: temperature, volume, mass of a gas, amount of a substance, and pressure. So these are the four important properties. These are the observable properties. So temperature we can observe using thermometer, volume is observable, and the amount of a gas and the pressure. Correct. So by considering these observable properties, bulky properties on the gases, all laws were explained. Okay, in this law at a constant temperature. Temperature should be constant and mass is also fixed. It's a fixed. Given a mass of a gas means fixed mass of a gas or amount of a substance is fixed. And the next is how volume and pressure is related. Volume of the system or gaseous system varies. How it varies? Inversely varies with the pressure. Inversely means ವಿಲೋಮಾನುಪಾತ. So ಕನ್ನಡ ಮೀಡಿಯಂದಲ್ಲಿ ಇದ್ರೆ ಇನ್ವರ್ಸ್ಲಿ ಅಂದರೆ ವಿಲೋಮಾನುಪಾತ. ಓಕೆ, ಸೊ ಏನಾಗ್ತಾ ಇದೆ, ಒತ್ತಡ ಮತ್ತು ಗಾತ್ರ ವಿಲೋಮಾನುಪಾತವಾಗಿರುತ್ತದೆ ಯಾವಾಗ? ಟೆಂಪರೇಚರ್ ಫಿಕ್ಸ್ ಇರುವಾಗ, ಕಾನ್ಸ್ಟಂಟ್ ಇರುವಾಗ, ಕಾನ್ಸ್ಟಂಟ್ ಅಮೌಂಟ್ ಆಫ್ ಎ ಗ್ಯಾಸ್. ಗ್ಯಾಸ್ ಅಮೌಂಟ್ ಆಫ್ ಎ ಗ್ಯಾಸ್ ಕೂಡ ಕಾನ್ಸ್ಟಂಟ್ ಇರಬೇಕು. ಓಕೆ, ದಟ್ ಈಸ್ ದ statement. According at a constant temperature, volume of a given mass of a gas varies inversely with the pressure. Okay, the same statement can be given in another way. Okay, in another word or suppose ನೀವು ಫಸ್ಟ್ ಟೈಮ್ ಈಗ ಇಂಗ್ಲೀಷ್ ಮೀಡಿಯಮ್ಗೆ ಬರ್ತಾ ಇದ್ದೀರಿ, ಇದು ಈ ಒಂದು ಥಿಂಗ್ಸ್ ಡಿಫಿಕಲ್ಟ್ ಅನ್ನಿಸ್ತಾ ಇದೆ ಅಂದರೆ ಈಸಿಯೆಸ್ಟ್ ವೇದಲ್ಲಿ ನಾವು ಸ್ಟೇಟ್ಮೆಂಟ್ ಅನ್ನು ಕೊಡಬೇಕು ಅಂದರೆ ಸೇಮ್ ಸ್ಟೇಟ್ಮೆಂಟ್ ಅಟ್ ಎ ಕಾನ್ಸ್ಟಂಟ್ ಟೆಂಪರೇಚರ್, at a constant temperature volume of fixed mass of a gas inversely proportional. varies ಅನ್ನೋದನ್ನ ಪ್ರಪೋರ್ಷನಾಲಿಟಿ ಆಗಿ ತಗೋಬಹುದು. ಓಕೆ, inversely proportional to pressure. In another word, so the same statement can be explained in this way: at the constant temperature, volume of a fixed mass of a gas inversely proportional to pressure. According to statement, how to explain the concept in mathematical or mathematical form of the statement is how volume is varies with pressure inversely. So according to the statement, volume varies inversely with the pressure. Suppose we consider the symbolical representation of volume V and the symbolical representation of pressure P. V is inversely proportional to P when at constant temperature. It's important. Okay, so constant temperature T. Okay, so this is the mathematical equation of Boyles law according to the statement. This proportionality can be explained in another way. V is equal to, or make it into equality. So by removing the proportionality, we substitute constant term. The constant term is explained or given using the symbol K. For the first law, I am using K1 because I am taking the proportionality in all the cases, in all the laws. Because of that, I am consider K1 for this law. Okay, you can use simply K also. It is also correct. V is equal to K1 divided by P. Again, at a constant temperature. Next, this one can be explained in another way. I am consider PV, P into V, which is equal to K1. What is the meaning of K1? K1 is where K1 is proportionality constant. Hence, PV is equal to constant. PV is equal to constant. So this is the another mathematical form of Boyles law. PV is equal to constant. The same thing explained in another way or in statement PV, the product of pressure and volume remains constant at constant temperature. Okay, or at constant temperature, product of pressure and volume constant. Okay, this is the another way of explaining the law. Using this mathematical form, the mathematical form is expressed in a graphical representation also. So what are the graphical representation involved in this law, and what happened when we consider the two system? It is only for one system. Suppose we consider two system, then so for first system pressure is P1 and the volume is V1. I am considering another system. Okay, in one system, it is a gaseous system. In the gaseous system, it contains volume V, and I am applying the pressure P1. Okay, volume has V1 and quantity, and pressure, applied pressure is P1 at a constant temperature. In another system, temperature remains constant. In this case, here volume become V2, another system, therefore I am considered V2, and here I am applying pressure P2. Then what happened? For this case, P1 V1 is equal to constant, and here also P2 V2 is constant. It is according to the statement. Okay, P1 V1 is equal to P2 V2. Both are constant. Therefore, it is the another mathematical form. It is only for solving the problems and all that. This is for two system, comparing the another system at a constant temperature. Okay, this one can be explained in another way also. By considering three or more system, then it becomes P3 V3. Okay, like that. So okay, next, what is the mathematical form or graphical form of this Boyles law? Suppose we put a graph of volume versus pressure along x-axis, volume along y-axis at a constant temperature. Okay, temperature is fixed. I am consider temperature is 300 Kelvin for a 300 Kelvin. Okay, at lower pressure, what happened? Pressure is very low, or pressure is released from the system, gaseous system, then automatically volume is very high. At temperature 300 Kelvin, just imagine the system has 300 Kelvin temperature and pressure is very low. Okay, ಒತ್ತಡ ಹಾಕ್ತಾ ಇಲ್ಲ ನೀವು, ಅವಾಗ ಏನಾಗಿದೆ, gaseous system ನಲ್ಲಿ gaseous volume ಜಾಸ್ತಿ ಆಗಿದೆ. ಓಕೆ, ಸೊ ಅವಾಗ ಏನು ತೋರಿಸಬೇಕು? ಗ್ರಾಫಿಕಲ್ ರಿಪ್ರೆಸೆಂಟೇಷನ್ ಹೋದಾಗ ಪ್ರೆಷರ್ ಕಡಿಮೆ ಇದೆ, ಸೊ ಹಿಯರ್ ಪ್ರೆಷರ್ ಕಡಿಮೆ ಇದೆ. ಡ್ಯೂರಿಂಗ್ ದ ಲೋವರ್ ಪ್ರೆಷರ್ ವಾಲ್ಯೂಮ್ ಇಸ್ ವೆರಿ ಹೈ, ವಾಲ್ಯೂಮ್ ಜಾಸ್ತಿ. ಗ್ರಾಜುವಲಿ ಪ್ರೆಷರ್ ಈಸ್ ಇನ್ಕ್ರೀಸ್ಡ್. ಗ್ರಾಜುವಲ್ ಇನ್ಕ್ರೀಸ್ ಮೀನ್ಸ್ ಕಾನ್ಸ್ಟೆಂಟ್ ಆಗಿ ನಾವು ಪ್ರೆಷರ್ ಅನ್ನು ಹಾಕ್ತಾ ಬರ್ತಾ ಇದ್ದೇವೆ. ಓಕೆ, ಒತ್ತಡವನ್ನು ಹಾಕ್ತಾ ಇದ್ದೇವೆ. ಸೊ ಇನ್ ಟರ್ಮ್ಸ್ ಆಫ್ ಎ ಬಾರ್ ಆರ್ ಇನ್ ಟರ್ಮ್ಸ್ ಆಫ್ ಅಟ್ಮಾಸ್ಫಿಯರ್. ಸೊ ಯಾವುದೇ ಒಂದು ಯೂನಿಟ್ ಅಲ್ಲಿ ಇರ್ಬೋದು, ಅಲ್ಲಿ ಪ್ರೆಷರ್ ಅನ್ನು ಅಪ್ಲೈ ಮಾಡ್ತಾ ಇದ್ದೇವೆ. ಆಸ್ ಪ್ರೆಷರ್ ಇನ್ಕ್ರೀಸಸ್ ಅಕಾರ್ಡಿಂಗ್ ಟು ದ mathematical form of Boyles law, at constant temperature, okay, we increase the pressure. When pressure is increases, volume goes on decreases, goes on decreases, goes on decreases. Gradually volume decreases. It is for what? Temperature 300 Kelvin. Okay, this graphical representation is for temperature 300 Kelvin. Now I am applying the temperature also for another system. Okay, just imagine I am consider another system. Here I am considered T2. Okay, it is, just imagine it is a 400 Kelvin. Okay, 400 Kelvin. What happened when temperature increases in generally? Okay, we don't know the other laws of gases and all that. In generally, when we supply the heat to any system, the molecules goes par each other or apart each other. So because of that, volume automatically increases. Correct? ನೀವು ನೀರನ್ನು ಬಿಸಿ ಮಾಡಿದ್ರೆ ಏನಾಗ್ತದೆ? ಸೊ ವೇಪರ್ ಆಗ್ತದೆ. ವೇಪರ್ಸ್ ವಾಲ್ಯೂಮ್ ಏನು ಜಾಸ್ತಿ ಅಲ್ವಾ? ಸೊ ವಾಲ್ಯೂಮ್ ಜಾಸ್ತಿ ಆಗಿದೆ. ಟೆಂಪರೇಚರ್ ಏನು ಮಾಡಿದೆ? 300 to 400. I am increasing the temperature. Simultaneously volume increases. There is another law. That part we discuss the next part. Okay. Temperature, when I am considered 400 Kelvin temperature, volume is slightly higher. Therefore, I am consider here. Okay, initial point. Same pressure. Okay, pressure is low. The pressure is equal to the first one. Temperature is the first initial same pressure. And consider temperature, another temperature. Because of that, volume is slightly higher. So same thing. Whatever the pressure we applied in the first system, same amount of pressure is applied. So again we observe another curve. So this curve is again gradual decreases of volume. Okay, again it is 42, it is 400 Kelvin. Similarly for another temperature. Okay, similarly another for lower temperature, lower than 300, more than 400 Kelvin, like that. Okay, suppose and consider these curves are for a constant temperature. Curves obtained from constant temperature. Constant temperature curves. These curves are constant temperature curves. The combination of these constant temperature curves are termed as isotherms. ಏನಂತ ಕರೀತಾರೆ? Okay, isotherms. Isotherms are constant temperature curves obtained in PV graph. Okay, obtained in PV graph. So what is the reason of using the word isotherms? The terms is stands for the temperature and iso same, constant. Correct? So we obtain the temperature curves, constant temperature curves. That's why we using the iso prefix and the terms temperature. It is related to the temperature, thermal energy. So because of that we call it as isotherms. For the remembering purpose, what is isotherms? Now ನೆನ್ಪಿಟ್ಕೊಳ್ಬೇಕಂದ್ರೆ, because ನಾವು ಬೇರೆ ಬೇರೆ ಲಾಸ್ ಅನ್ನು ಸ್ಟಡಿ ಮಾಡಿದಾಗ ಐಸೋಥರ್ಮ್ಸ್, ಐಸೋಬಾರ್ಸ್, ಸೊ ಆ ಥರ ವರ್ಡ್ಸ್ ಬರ್ತಾ ಹೋಗ್ತದೆ. ಸಿಮಿಲರ್ ಪಾಯಿಂಟ್ಸ್ ಇರುವಾಗ ನೆನ್ಪಿಟ್ಕೊಳ್ಳಿಕ್ಕೆ terms is related to the temperature. Iso same, constant temperature curves. Okay, when we obtain constant temperature curves in PV graph. So this is for PV graph. Okay, then what is the definition of isotherms? Isotherms are the constant temperature curves obtained in PV graph. Okay, in the same case I am consider another factor. That one is one by P versus V. 1 by P along the x-axis and volume along the y-axis. So this graphical representation is V versus 1 by P. What happened when we plot a graph of V versus 1 by P? What is the statement of Boyles law? Boyles law states that volume is inversely varies with the pressure. Correct? What happened in this case? 1 by P. I consider 1 by P. The whole factor or whole things is directly proportional now. Correct? V is directly proportional to 1 by P. That's why we obtain a straight line when we plot a graph of V versus 1 by P for a temperature. It is for temperature, higher temperature, then it is T3. Okay, for lower temperature T1 and next and the next one. Okay, a lower temperature we obtain the straight line which is below, and for a higher temperature next to the straight line another straight line. What is the reason of we getting the straight lines? Because v is directly proportional to 1 by v. Okay, I think these things understood now. Next we move on to the relation between volume and the density, or pressure and the density. Okay, what happened in case of a gaseous state? What are the things we discussed in the previous part? The gaseous properties. Though in case of the properties of a gases, we saw one thing. Gaseous molecules are highly compressible. Correct? Gaseous molecules are highly compressible. So these gaseous molecules are far apart each other. These are highly compressible. When we apply the pressure, it compressible. What happened when pressure is applied? When we apply the pressure P, the molecules come near to each other, and simultaneously the system, gaseous system, become more denser. What is the density? D is equal to m by mass by volume is density. So in one small region, how many molecules are there? Depends upon that we find out the density, correct? If there are large number of molecules in a small region, mass increases, volume decreases, density increases. ಅಲ್ವಾ? ಸೊ ಏನಾಗ್ತದೆ, ಸಾಂದ್ರತೆ ಅಂದರೆ ನಾವು ಸಣ್ಣ ಒಂದು ರೀಸನ್ ಒಳಗಡೆಗೆ ಜಾಸ್ತಿ ಮೊಲಿಕ್ಯೂಲ್ಸನ್ನು ಅಬ್ಸರ್ವ್ ಮಾಡಿದರೆ, ಸೊ ಅಲ್ಲೇನಾಗಿದೆ, ಮಾಸ್ ಜಾಸ್ತಿ ಆಗ್ತದೆ, ವಾಲ್ಯೂಮ್ ಕಡಿಮೆ ಆಗ್ತದೆ, ಸೈಮಲ್ಟೇನಿಯಸ್ಲಿ ಡೆನ್ಸಿಟಿ ಜಾಸ್ತಿ ಅಲ್ವಾ. ಸೊ ವೆನ್ ವಿ ಅಪ್ಲೈ ದ ಪ್ರೆಷರ್, gaseous molecule come contact each other or comes near to each other. Because of that, volume of the system decreases, mass of a gaseous system increases, simultaneously density increases. Correct? So denominator term, so because of that density increases. So according to this experiment or observation, pressure is directly proportional to D. Correct? When we apply the pressure, density increases in gaseous system. So for this experiment, it is proved in mathematical form also, using the mathematical law or mathematical form of Boyles law. How P is related to V? P is inversely proportional to V, or P is equal to K by V. What is K? Proportionality constant. And what is density? So suppose it is the equation number 1. Okay, consider it is the equation number 1. It is according to Boyles law. Okay, P is inversely proportional to V. P is equal to K by V. Equation number 1. Now, according to the definition of density, D is equal to m by V, and here V is equal to m by D. Suppose it is equation number 2. Substitute the value of V in equation number 1. What happened when we substitute 2 in 1? Now P is equal to okay, V here denominator term K divided by m by D. Correct? I am substitute the value of V in equation number 1. Now P is inversely proportional to m by D. P is equal to D goes to the numerator, D A M. And what are these things? For a given a mass of a gas, mass is constant. Given a mass means fixed mass. Fixed mass means mass is known, quantity, amount of a substance is known. So therefore m is constant, K is constant, P is equal to constant term capital K into D. Suppose we remove the constant, proportionality constant, the equation get converted into equation number 3 converted into P is directly proportional to D. It is proved, correct? So in experimentally and in theoretically, the pressure is directly proportional to D. Okay. So this is the another derivation form for giving the justification of pressure is directly proportional to D by considering Boyles law. Okay, so these are the things we studied under the Boyles law. Next video we will discuss about the second law of gases. Okay, thank you for watching.